Okay, welcome back. Today we're going to work on a fuselage aft side panel. Let me take a minute to go through what I've already done at this point. So this was just a blank sheet here that was cut to size, and it did have pilot holes in it. You can see some of the pilot holes here already. What it did not have was several holes cut in it, so you can see this little oblong sort of circular cut hole here. That's for the rudder cable to come out and connect to the rudders on the other ends. Here's a hole that I had to cut in it for the inspection panel that's going to go over the top of the hole here. And then up here in the front, here's a hole for the flap control that's going to come out the side here. And then you'll notice right here in the front as well, there's a slight little downward bend, 10-degree bend that goes from the skin here 10 degrees down. And I'll try and lift this up without making a big mess here, but so that's what it looks like on the inside with those ribs all up along the inside that we worked on in the last video. You can see the phenolic blocks right there on the front side and back on the back side over here too. Here atop my sawhorses I have my two forward side panels connected with this C channel here that's going to go over the top of the wing connection. These are just clecoed into place for now, waiting for a little more assembly. And then I still need a place to work, so I built a workbench over here. I'm going to need to have this kind of sitting in the middle of the garage for quite a bit of time, probably for the next year or two as I finish up the rest of the airplane. And it's mostly going to be sitting on top of this set of sawhorses here. And so on the side of the garage over here, I've built a table that's connected to the wall. And these legs here, they are able to fold in against the wall, and the whole thing will actually sort of, so those legs will fold in against the wall that way, and then the whole table will fold down, giving me enough room to kind of walk between where the airplane is and the wall and give myself some space in here. I've also added to the tops and the bottoms of these legs here, there's some adjusters up inside of this, and down on the bottom there are these screw-in, I don't know if you can get in there and see it or not, but it's kind of a screw-in adjuster here that'll lift the table up slightly on either side so I can try and get it square, or level I should say. And it also has the same thing on the bottoms of each of these down on the floor. Probably the most significant change in my garage is this Rotax 912 ULS that's sitting in the corner. I just picked this up last weekend. It's a used engine. It has 893 hours on it, and it was built in 2007. There's a bit of a story behind the engine. I found it on Barnstormers, saw that it was in Maryland, so I contacted the guy. He gave me a little bit of information. The guy that I bought it from had two different engines, and I passed that information on to two of my friends who both have 912 ULSs in their RVs. And one of them is a certified mechanic for light sport airplanes. He actually said, yeah, I know the guy, and I also happen to have worked on both of these airplane engines. In fact, I'm building carburetors on one of them right now. Anyway, so I had my two friends come with me to go down to do sort of a pre-buy inspection on it. And as we're looking it over, everything looked really good. It came with a lot of the parts that you might not get otherwise. You know, it has a starter on it, has all of the electronics, it has a oil cooler, it has a water cooler in it. It also has the oil tank that's kind of sitting over here in good shape, and then a bunch of gauges that came along with it as well, and even a voltage regulator as well. So all in all, it's a pretty good, I got a pretty good price on it. Obviously I'm not going to be able to do much with that until I actually buy an engine mount. The kit that I purchased was bought from a previous builder. When they ordered it from Sonex, they actually bought it with a Jabiru engine mount. So I'm in the process right now of figuring out what all parts I need to do for an engine mount for it. Sonex actually has two of them. One of them is a bed mount that it sits on top of, and then there's another one that's the ring mount that's supposedly a little bit stronger and sturdier. I have emails in with Mark Schabel at Sonex. He's been giving me some updates and some ideas on what I should do. And then he also forwarded me over to Casey Cooper, who has a cooling system that he's designed to go with the 912 series Rotax engines. So that's all going to be farther down the road. I found a good deal on the engine, and I just wanted to make sure that I had one sitting here for when I'm ready to go. And it seems like it's in pretty good shape. All right, so let's get down to business here. Today we're going to be working on the Fuselage Aft side panels, which you can see here. You can see that it doesn't have any of the holes in it or the bend. It's going to go along this line right here. There's going to be a hole that's drilled here. There is one slight difference between the left and the right side. This is the left one, and it doesn't have the oblong hole that was for the flaps here. It only has a circular one. So this side should be a little bit easier. What I had to do in the last one is actually drill a hole the right size in the front, and then a smaller one that was in the back, and then actually cut grooves down the side to make that oblong sort of two different sized circular holes here. And then down here, the inspection plate's actually a little bit farther forward on the left side than it is on the right, so it's kind of right up here. I've already marked it, ready to go. And up here's where I'm going to cut out the slot for the rudder cable that's going to come out the side of the side panel here. First things first though, we need to cut these long longerons here. Mark them as well already. There's a kind of a groove that needs to be cut out of it. It needs to be tapered because it needs to match the bend on the front side of this side panel here. So we had to mark this. See if I can get this in focus. It's not going to do it. There we go. So I marked it here. This is the top, the upper longeron. It's a single bevel going this direction. And the bottom one here, it actually has two different directions. So it has to be beveled to the side as well as slightly inward down here. So the tail will actually kind of come up a little bit here as it connects into the bottom here. And so there has to be a little bit of an angle to make that meet squarely here. One I think turned out really well, exactly as marked, and I'm happy with the way that turned out. Next step is that I need to cut this at a specific length from this corner here back to the end over there. I've got to mark it and cut it. You might be wondering why I cut it a little bit long and I'm using the file to take it down to the correct dimensions. A couple of reasons for that. Number one, I want to make sure that it's very precise. I get the cut exactly where I want it. And then it's also very square without cutting off too much. A hacksaw is not really a great way to cut this. Which brings up another question. Maybe you're wondering, well, why didn't I just use like a cutoff tool or like a Dremel or something like that? And the reason for that is because this is 6061 T6 aluminum. The T6 means that it's tempered for a certain kind of strength, and that tempering is done through heat treatment. And if you heat this up too much using some kind of a cutoff tool such as a Dremel that uses friction, you stand the chance of ruining the temper and actually making the part weaker or more brittle, depending on if it gets quenched or not. And so using hand tools and going slowly, it keeps it from overheating, and it'll hold its strength even, after I've done the cut. Alright, so here's the one that's going to be a little more difficult to do. It's got kind of two different dimensions on it that I need to file down. But again, I'm just going to do this with the file. I'm not going to put a hacksaw on this and end up kind of mangling it. So everything's square right now. I just need to kind of file this down according to these lines that I've drawn. Alright, now that we've got all of our holes drilled into our side skin here, so this is the inspection hole up here, and this is the hole that we put in here for the flaps. We also added in this same little notch down here for the rudder cable. The next thing we have to do is bend this end of the sheet up 10 degrees. And to make that a little bit easier, I have 3D modeled and 3D printed a little gauge here that it bends up 10 degrees. If I lay this flat, you can see that it's kind of proud a little bit here on this end by about 10 degrees. And that will allow me to bend this up and use this to make sure that it's bent the right amount. And to bend the metal, I'm going to use the sheet metal bender. It's a little bit too wide. The sheet here is a little too wide to work with my metal brake. The metal brake, I think, is only like 20 inches wide or something. I think this is 22 or 24. So it's just slightly too wide. On the other side panel, I was able to bend it with this with pretty good results. We'll do it again, and I did have to tweak it a little bit with the hand tool. A couple of spots it didn't bend quite as much as it did in other areas. The secret here is just to make sure you don't bend it too far, because we don't want to bend it back again. So let's go ahead and do that. We've got our little tool here to make sure that we have it bent the right amount, and we'll verify that after each try here. Alright, there's our 10-degree bend. And I also drew a couple of lines up here before I bent it. There's a part that needs to line up a 32nd of an inch beyond that 3/4 inch line there on both sides. You can see this one a little bit better. But there's a part that we line up here next when we do all this. So one thing about the longeron along the bottom is that it says that you should have the width of a skin across the bottom. So I have a cut off piece of skin here from another part, and I'm actually going to use that as sort of a template to know how far to put the longeron away from the bottom edge of the skin here, just to make sure that it has enough room so that when we put the bottom skin on, it sits flush against it. One of the hardest parts here is getting, let's see if I can even get this into focus here, but where I have that second line drawn, I've got to pull the skin to the point where it's just lined up with the second line up inside of here. I'm going to turn the camera off so I can do this properly without worrying about whether the camera's got it in sight or not. And then I'll go ahead and clamp it down to the table all along the side here to make sure it's all in the right spot before I go ahead and start drilling out the holes based on these pre-drilled holes here in the skin. Alright, I've got it lined up and measured out. Here's this little piece that I was talking about that allows me to check to make sure that it's nice and flat here. That's lined up the way it should be, and it is. No play between those two. I've got it a couple of these notches down here as well. Farther down I go, this angle kind of bends inward a little bit, so as I go along I'll make adjustments and pull it out to the right spot a little bit more. Well, I didn't get this on camera, but I went ahead and added this rudder stop here as well. What I did is I used a couple of these vice grip clamps here to kind of hold it in place. I made sure it lined up exactly where it's supposed to line up here along the bottom and along the back of the skin here. And I used a couple of these guys to hold it in place while I drilled it from underneath, where the holes are already pre-drilled in the skin as well as partially in this longeron here. So there it is. Alright, now I'm going to go ahead and remove all of these clecos where it's actually going into the table. I like to drill into the edge of the table here to hold everything steady and in place while I attach the skins to make sure it's lined up properly. It should have, I think it's 32 mil between the skin here and the bottom of the longeron here. So when the bottom skin hits that, the skin is flush with the bottom of the side skin here. So at this point it's kind of still stuck to the table. Clecos are going into the table, so I'm just going to pull out these clecos all along the length here, except for these couple of spots where the table kind of ends right here. So I'll leave these in place just to hold everything together, and then once I get the part pulled off the table, I'm going to turn it around, kind of do a little 180 here, and then we're going to put the top longeron on this part right here in just the same way. Well, in retrospect, I don't like how far this bottom longeron, which is now on that side of the table, I don't like how far that's keeping it up off the table. I don't like how much of a bow that puts in the skin if I clamp that down. So I'm going to go ahead and pull out the rest of these clecos here and let it lay flat while I go ahead and drill this one out. Cool. Well, using the camera actually worked really well to get that all lined up from underneath. I didn't have to climb on the floor like I did with the last one and look up at it. I was able to kind of zoom in right on that line and line up the longeron where it needs to go. Alright, so all these pilot holes are drilled in the upper longeron. I'm going to go ahead and pull out these clecos because it's, again, attached to the table. It's stuck on there right now. And then I'm going to add on these vertical channels that are going to go in all these holes along the vertical side of this side panel here. Alright, up to this point everything's been pretty straightforward and pretty simple to do. These vertical channels here are also pretty straightforward. They're mostly pre-drilled. In fact, I think they're all pre-drilled. The more difficult part of this is going to be these splices here. This is the one that attaches to the lower longeron. And here's the one that attaches to the upper longeron. And what I found that works the best, if we come over here and look at our instructions, the thing that I found that makes this the easiest to line them up, you can do all the measuring and all that stuff, but there's always going to be small imperfections in how these are milled out and everything. What I found works really well is if you look at this diagram right here, there's a center hole that's in the side of this lower splice right here, and that needs to line up with the holes. You can just barely see it on the drawing here of the Z as well as to the side skin here. So here's our side skins coming along the bottom of this, and then it has a 10-degree bend, and there's a hole drilled right into there. It's a little bit farther inboard than this, but you can trace those lines. So here's kind of another example from the top view here. So what I've done here is I've traced a line between these two center holes all the way back, all the way to the end of the part here. And that line needs to line up with this hole right here. And so as long as you have the hole on the splice, remember it's got a 10-degree bend on it, so you've got to kind of look at it, slide a sort of 10 degrees off to make sure that you're lined up perfectly. But you can just kind of peek through that hole right there to where the line is drawn, and that lines everything up as long as you have that. So the same thing happens here on the upper splice. There's also a hole here that, you know, I drew a line from the holes down here that are already pre-drilled to make a center line right through that hole. And then I just line that up, and it puts everything else into place. Again, you could measure it, but getting to 21/32 or 1/32 you know, 1 inch and 30 seconds or 3 and 21/30 seconds, I'm much more able to do that measurement by peering through this hole and making sure that's lined up than I am by pulling out a tape measure and all that and trying to see if I can get it right that way. So that's what I'm going to do on here. I did it on the other one as well, and it turned out, I think, really well. So I'm just going to continue doing the same thing on this one. Alright, so in order to prepare this to make it a little bit easier, like I said, I've drawn a line, center point to center point in these two holes here, and I've drawn that all the way out to the outer edge, or to the lower edge of the side skin here. There's a slight bevel here that then straightens out to 90 degrees, so I put my square up against that and drew the line perfectly between here. And then this hole right here, it's going to be hard to see probably in the camera, but I'm going to push this forward up until it lines up with that line that I drew below. And as soon as I get that lined up, I'm looking at it from behind the camera, making sure it's lined up. The camera might not get it exactly lined up, but there you go. So that hole lines up with this line beneath, which puts this part exactly where it needs to be. Now this side over here, there's not a really good way to drill to get this. I don't know why they pre-drilled this side of it. It doesn't make a lot of sense. But this is where we are. I've made sure that the line is where it needs to be, measured the distance between here and here. So for this forward one here, so I put the marker in over here, made a mark, and then I was able to mark around here 90 degrees on all sides, and then this is all the same height here, distance from this top edge down to this line here, and that makes all the parts line up. Alright, so I have everything lined up here. I've got this line here that I lined up. The hole up inside of here is lined up with the line, and next I'm just going to go ahead and drill these two holes right here and right here, and put some clecos in to hold everything in place while I drill the additional holes that go inside the side here, this direction. Again, I'm going to have to drill this one from this side. I think I can get my longer drill bit in to drill in from this side over here without any issues. So I'm not going to trust the marks that I made on this side. Just make sure that everything's lined up the way it should on this one. But all in all, that turned out pretty well. Both of those holes kind of ended up right where we wanted them, and everything's still lined up the way that we want it to be lined up. I'm going to call that a win. Same thing with this upper splice here. Drew a center line to center line hole from here to here and continued it out to the end. I'm able to peer down this hole in the splice and see that line. And if I line this up here, you can also see that those lines all line up. And then I've got several holes to drill through here, and then two going down as well. This direction here and this direction. So I'm just going to go ahead and drill those holes with the elongated drill bit, just to get around all my tools that I want to have there holding everything in place and nothing moves. the upper splice is drilled and attached here with clecos, and everything's still all lined up the way it should be. Alright, well, everything's attached as it should be, and I'm going to go ahead and start doing the up drilling here. All of these holes along the bend here, they're going to stay at 3/32, excuse me. All of the upper longeron here, that stays at 3/32 as well. And then all these holes going down the lower longeron and these vertical channels, they all get up drilled to 1/8 inch for the 1/8 inch rivets, and then these holes, the second one's in up here, this also gets drilled up to 1/8 inch, so this will go up to the copper clecos as well, but this will not get riveted. Just from this hole down gets riveted. This top one we leave not riveted, but drilled and deburred. If you take a look at this one that I have complete over here, it's the same deal. Everything's all riveted up from the bottom up until that top one that's almost the top one, the second from the top. That just has a copper cleco in it, and then the one above it is not drilled at all. That's where the turtle deck's going to eventually get attached, and we need to drill all those parts in together. And then I believe that these copper clecos here, the second one up, just we can pull that out so that the skin can bend enough to be able to put the turtle deck down inside of there and move it around as necessary. Alright, well that's where I'm going to end this one. I had a couple friends come over and help me pull the rivets, and now I've got two side panels. I've gone ahead and assembled the two of them together just temporarily, just to kind of see how it looks. Anyway, things seem to fit pretty well, and I'm happy with how that turned out. Well, thanks for hanging out with me for a little bit. If you haven't subscribed already, consider doing so. My wife and I are going to be taking a trip off to Italy for a couple of weeks here, and so I won't be back on YouTube for a bit. Have yourself a good couple of weeks, and we'll see you when we start working on the next part. See ya.